Okay, so we're starting our new set of notes, new unit, types of chemical reactions. Chemical reactions are pretty fun, really. And generally, well, I don't want to say not hard, but today shouldn't be that bad. So we're just going to go over the 5 types of chemical reactions that we're going to be discussing. There's not the only types, but they're the main types. And you will get to see these in demonstration. And if you are in person, we will actually have a lab coming up. More than one. We'll do a couple labs because chemical reactions, obviously it's a chemical reaction. They offer a lot of opportunity for labs. So definitely our lab heavy unit after a while without those. Okay, so first off, we have a chemical reaction, just regular. Okay, so chemical reaction, process in which substances with different properties are formed. That's what a chemical reaction is when I mix something together and new things are formed. A chemical reaction a chemical equation is this, a written representation of a chemical reaction in either words, so word form, or chemical formulas. So we are going to be looking at a chemical equation, I guess, for the first time and seeing how when I look at the chemical equation, how can I tell the type of reaction it is based on the way it looks? So in looking at how this is set up, you are always going to have reactants on the left side of the arrow and products to the right. So the reactants react together to create the product, okay, on the other side. So let's go fill that in. So the reactant, what you start with in a chemical reaction, so it's what I start with, so this is reactant and reaction are to the left of the arrow. So left, or I drew a little sign, okay? So it's these ones. I'm going to go ahead and label them. This is a reactant, and this is a reactant. So when hydrogen and oxygen react together, they produce, so to the right of the arrow, what you end up with is what is produced, so is your product. Okay, like that. So you have reactants and they're forming a product. It's all based on this arrow. This arrow means yields. So the reactants yield a product. So same thing here. This is a reactant, this is a reactant, and it's producing a product. You will need to know those vocab terms. Reactants are to the left of the arrow, and products are to the right. It's not always 2 reactants and 1 product. It could be 4 reactants and 2 products, or only 1 reactant. 1 reactant that just breaks down into several products. So it can be anything, but the reactants are always to the left, and products are always to the right. So the arrow stands for, again, like I just said, yields. So it yields or produces or equals. All those things should be true. The 2 sides are always equal to each other. So there's just as much of one element on one side of the equation as there is on the other side. They will be balanced. So they will equal each other. But it does stand for yields and produces. The arrow stands for. We'll learn a couple more symbols later, but that is enough for today. Come on now, let me scroll. Is that enough? This light won't let me click. So apparently I'm going to have to walk back and forth. Awesome. So I'm going to scroll down. Now we're starting our 5 types of reactions. There are 5 general types of chemical reactions that we'll discuss this year. The first one, the one that most everybody loves the most, is called a combustion reaction. Okay, a combustion reaction. I'm going to kind of shrink this actually since I'm over here so I can fit it more on one page. There we go. So a combustion reaction is a reaction with oxygen, so there has to be oxygen. Okay, that is something that is the most specific. The combustion reaction is the most specific reaction that we will discuss. It has very set things that always have to be in it, or it's not a combustion reaction. So a reaction in which oxygen reacts, so it has to be on the reactant side. It can't be on the product. Well, it is on the product side too. But there's oxygen by itself on the reaction side with another substance, usually producing heat and light. Okay, so these are the ones that go kaboom. These are the ones that create fire. All right, so these are the more fun ones generally to do as a reaction because they, go kaboom. So combustion reactions result in the production of oxide of each of the elements in the fuel. So we have some kind of fuel source. Since we'll be dealing primarily with the combustion of a hydrocarbon, Why is it all off lines again? I don't know. Hydrocarbons, which means they have a hydrogen and a carbon. What do you know? Hydrocarbon, they have a hydrogen and a carbon in them. And they will produce an oxide. So we'll produce an oxide, and they will produce a water. So it's like that every single time. I don't know why it won't let me draw an underline. So basically what it's saying is on the reaction side. So my reactants over here are always going to be a hydrocarbon. Hydrocarbon. Okay, so that's our fuel. That hydrocarbon is going to burn in the presence of oxygen. So remember, oxygen makes things burn faster. When it is reacting with that oxygen, it is going to break itself down into carbon dioxide and water, which is H2O. Okay, so these are our products, and this is always true for the combustion reactions that are really easy to identify because you're going to notice it's a hydrocarbon with an oxygen, and then on the product side, it's going to make either CO2 or CO. Either one of those. Either one is fine. It's either carbon dioxide or carbon monoxide. It can make either one. Carbon monoxide would be worse for us breathing it. It's more poisonous. But still, it can make either one, and then water. Okay, so every time, if you haven't noticed, in a little fuel burning incident, there's always like a little bit of like water residue left behind. If you're in person, you'll get to see that in class. Anyways, so these are the easiest to identify because it literally always has those parts. Nothing else. It's going to have a C and an H. It's going to bond with an O2 by itself, and it's going to make either CO2 or CO, and then water. That's it. It's going to have those four things. If it doesn't have those four things in that order, it's not combustion. All right, let's scroll down to the next type of reaction. So the next type of reaction is called an addition reaction. It is also called, I don't usually call it combustion. It gets like weirder the further up I go. Like it gets even more wrong. I'm gonna put synthesis, because that's what a lot of people call it, especially if you were older like me. It was called a synthesis reaction, not an addition reaction. But we'll usually call it addition because I think it makes more sense for what happens in the reaction. But synthesis is what it used to be called because synthesis is an English word for adding together. Okay, so a reaction in which two or more elements, so it could be two or more elements or compounds, it just has to be two or more things, form a larger compound. So two or more things form one, that's important, form one larger compound. Okay, so it's like I have an element with another element and it forms a compound. Boom. They reacted together, they bonded, have a compound. That's an addition reaction. That's two things coming together. It could also be a little compound, so two elements with another compound that bonded and to become an even bigger compound. That's still an addition reaction. It's just you have to have little things that join into one big thing. So little things that join into one big thing. So I have to add more than one thing that adds into one bigger one. Okay. So if I draw like a little picture of what that could look like, it'd be like I have an element bonds with a different type of element. So I'm going to make it a different, solid color. There we go. And then it creates a compound of them being together. It's hard to color. Okay, like that. So for example, if I have copper and that copper rusts with oxygen, so oxygen's outside and it's rusting the copper, it will turn into copper oxide. So little things made one bigger thing. I could also have a compound like magnesium oxide that bonds with carbon dioxide and makes a bigger, so one bigger compound, magnesium carbonate. They just bond it all together. Okay, so it's little things that come together and create one bigger thing. It's an addition reaction. And you will get to see all of these reactions either virtually or actually in person, so you kind of get a better understanding of them. But we first are just going to learn how to classify them. The next reaction is the complete opposite of addition reaction. It's decomposition. So when you think of decomposition, remember you're thinking of things like decomposing, things breaking down. So it's when a compound has to be a compound to start, because you can't break down an element. So it has to be a compound to start, and it's going to be broken down into two or more simpler substances. So it doesn't really matter how many pieces it breaks down into, but it's going to be one big thing that breaks down into pieces. So on our last reaction, the addition reaction, it's little things that add into one big one. This is going to be one big one that breaks down into little ones. Okay, so we have compound breaks down into its elements. We have a bigger compound that breaks down into two smaller compounds, but it's still something bigger broke down into two or more things. So if I was going to draw the opposite of our previous picture, it'd be like I had that compound, they were bonded together, some kind of energy made them decompose, made them split, go through a chemical reaction that separated them back into their parts, back into their individual parts, like that. Okay, so an example would be hydrogen sulfide, goes through reaction and breaks back down into hydrogen and sulfur by themselves. Calcium carbonate that goes through reaction and breaks down into calcium oxide and CO2, which is carbon dioxide. So it just breaks down from bigger compound to littler compounds. Either way, it's one thing, breaks down into several pieces. Okay? Now we're going to do single and double replacement. So that was addition and decomposition. A single replacement reaction is, hence the name, has a single. It's going to have a single element that's going to replace another element in a compound. So it's a reaction where a single element replaces the similar element. It's not going to kick out something that's not like. It's going to kick out the most similar element to it from a compound. Okay? So seeing how that would kind of look, we have an element by itself, a single element. We have a compound. This element right here, A, is going to kick B out. It's going to kick him out. I guess that's not how I'd actually want to draw that. B is like this. It's going to kick B out. So now B's by itself and take its place. So it makes the B single and A joins the compound. Or we have a Y. So this is like a non-metal. So this would be like a metal kicking out the metal and joining the new non-metal, right? Over here, this is like the non-metal, so it's going to take out the similar one, so it's going to kick out X. It's going to kick out the other non-metal and take its place, leaving the non-metal again single, so the different non-metal X single, and taking its place in the compound, becoming A and Y. So you see that it kicked X out, so now X is single, took its place in the compound. So there's always going to be a single element on both sides of the arrow, both sides of the reactant and product side. There's always be something single. It's just going to be a different element single because one of them takes its place. Okay, so for an example, when iron comes into contact with copper sulfide, iron has a stronger pull than copper does. So he'll kick copper out, make copper sad and single now, and take its place in the compound. Now it's iron sulfide instead. Or we could have chlorine. Chlorine is a non-metal, so it's going to kick out bromine. It's always going to kick out the thing that's most like. If it's a metal, it's going to kick out the metal. If it's a non-metal, it's going to kick out the non-metal. So chlorine has a stronger pull than bromine does. So it's going to kick bromine out, make him single, and take his place with Ba, with barium. Take his place in the compound. So I usually draw little silly people. So I have like a boy meets a couple. Okay, so we got a little couple going on here. Give her some little hair. We'll give him some spikes like that. He comes up and he's just more attractive to this lady. He takes his place. He kicks that guy out. So poor spiky-haired man is now single, and our bald man takes the place in that little coupling like that. Okay. So that's the mean reaction. This one of the singles kicks the other single out and makes them lonely. Okay. Pretty sure this is the last one. Yes, it is. Double replacement reaction. So double replacement reaction is just like the single, except for instead of being a single being replaced, it is when two compounds replace each other. So two compounds switch. They switch to form new compounds. All right, so I have an A and an X, and I have a B and a Y. That A is going to join with a Y, and that B is going to join with the X. So it's always a metal and a non-metal in these cases. It's always an ionic compound. And then the metal from A is going to join with the other non-metal Y. And so they're just going to swap metals with a different non-metal, and then they'll get a new metal with a non-metal. So it's always a metal, non-metal compound. Okay, so they make new ones. So now it's A with Y and B with X. So to see that in like a real life example, so we have silver. Silver is a metal and it's first. So the metals are always going to join with the non-metal. It's always the first or the last thing. Now this metal, sodium, Na, is going to join with the other ones. Well, not really non-metal, this is a polyatomic ion, but it's a negative thing, and it's the second thing in the compound, the NO3. So when they do that, the silver and chlorine are together, so silver chloride, and then Na and NO3 are over here. Now notice, eventually you're going to have to like kind of predict a reaction, and notice how sodium is written first. So over here, sodium is written first, it still is. Over here, silver, Ag, is written first, it still is. Okay, so metals are always written first. The second thing, so NO3 was second, it was the second thing in the compound, well, it's still the second thing in the compound. So the order you write them in does matter. It's always metals first, the non-metal or the polyatomic ion second. And in this case, if I was going to draw a silly picture, so let's draw some little people. Let's give her a ponytail this time, and we'll give him a mullet. I can't really draw a mullet, but I tried. Okay, a little ponytail, a little mullet, and they're going to come over here, and they see this guy, and he has one tiny hair, joining the girl who has really, really long emo locks. Okay, that's what she's got going on, and they're going to decide that they'd be better suited if they swapped. So they're going to switch partners over here. So it's like a little dance routine, like you're do-si-doing. Okay, so we're do-si-doing, switching partners. So now we have mullet guy is going to be with emo long-haired chick. They're going to switch in their little dance partner. And now we have one-haired guy is going to be with our chick with the ponytail. Okay, so they just swap partners or they swap compounds. They're switching. All right. Now I'm going to scroll down. Last thing is just to go through a couple practices. This practice will be exactly like the worksheet you were about to be required to do. You're literally just going to have to tell me types based on what you're seeing. Okay, so this first one should be the most obvious. I have a C and an H. That's a hydrocarbon. I have oxygen, so it's a hydrocarbon burning in the presence of oxygen, and it always makes either CO2 or CO and water, H2O. It has all four parts. It has all four parts of the first type we talked about, which is combustion. Okay. The next one has two elements. So element forms a compound. So two elements form one compound. So two things coming together. That is a addition reaction. It's just everything on the reaction side becomes one thing on the product side. Now over here, I got four compounds. And it's not this one. So combustion has four compounds, but it's specific compounds. It's always a hydrocarbon. Always actually, that's not a compound. That's three compounds. So I lied. This is the only one with four compounds. So we have sodium, and you notice over here, it swaps partners. It takes the chlorine from chromium. And chromium switches to having phosphate, the PO4, makes a new compound. So when we have a double swap like that, that's called double replacement. Put way too many humps on my end, but all right, there we go. Okay, this one, we have one compound breaking down into two smaller elements. We have one thing breaking down into pieces. That is decomposition. Decomposition. Things breaking down. One thing broke down into pieces. That's decomposition. Okay. Now we have an element. Oops, it's not letting me right there for some reason. Why? I can write everywhere else, but not here. This is an element. This is a compound. This is an element. This is a compound. Lets me right over there. That's weird. Maybe if I move my mouse. Yes, so that's still mad at me. Okay, I get it. So that is an element with compound with an element and a compound on the other side, but the element is different on both sides. It's a different element by itself. So it's a different single, the single swap. So this single kicked this single out, made him sad and lonely over here, and took his place. So that is a single replacement reaction. We'll talk about why they do stuff like this later, but these are just the types, the broad types. We'll talk about how they do this and why they do this in more detail later. All right, and last one. Notice how these are very much alike. It's no longer letting me write over here. I don't know why. Okay, there it goes. So those, notice how they are similar. Hydrocarbon, hydrocarbon. Burns with oxygen, burns with oxygen. Creates CO2 or CO. They're very similar. And always water, water, H2O. So it has all four parts. Again, that's combustion. So as you can remember those four parts, it should be the easiest one to identify. It's always those four things in a row. Different numbers maybe on the C's and H's, like that C3H6 at top, and this is CH4, but it's still a hydrocarbon, burning with oxygen, creating CO2 and H2O. Okay, there we go. That's the notes.